In this chapter, we are going to introduce the approach of model checking. First, let's take a summary of the different approaches to analyzing programs that we're looking at. Program verification is based on having predicates at some or all of the nodes of a program graph. Whenever we add a certain node, having a certain predicate, and a memory that satisfies a predicate, what we need to ensure is that once control reaches another node in the program graph with a predicate, that the memory there will also satisfy the predicate. Program analysis is an automatic method that, so to speak, will compute the predicates automatically based on iterative analysis of the program graph. Correctness of the analysis result will be guaranteed if we construct the analysis in the appropriate way. Model checking is a technique that uses formulae in a restricted logic to express the properties that we're interested in, and then finding out whether or not these properties hold is based on reachability analysis within the model, which is here called a transition system. Model checking is not quite as expressive as program verification, but it can be fully automated. Model checking is generally more precise than program analysis, but the complexity of performing model checking is often much higher. So far, we have been looking at program graphs and memories. Program graphs represent the control structure of programs. Memories tell us the values of variables and array entries. We then had the notion of a configuration, which consisted of both a node in the program graph and a concrete memory. And an execution step explained to us how to move from one configuration to another. This is where model checking takes off. It is based on transition systems where the states correspond to what we used to call configurations, and where so-called transitions corresponds to what we used to call execution steps. However, when we look at one of the states, it may not be so clear which part of the state corresponds to, say, a node in a program graph, and which part of the state corresponds to, say, a memory.